I'm Joel Sliwka. I'm the CEO and founder of Grindr. So I wanted to welcome you guys to our talk tonight. Before I introduce Lukas, I just want to give you a little bit of background on Grindr. We've been around we just celebrated 5 years a few months ago. 5 years a few months ago. And we've started here in Los Angeles. And actually, I was telling someone we're in my living room for about 2 years. And now we've been here in this office for about a year now, a little less than that. And we're global. We've about 5 million, over 5 million monthly users who go on at least once a month, and on a daily basis we have about 1.5 million who use the service every day. Concurrent, we're about 300,000, 250,000 users who go on any given minute. So a lot of traffic, a lot of usage, a lot of guys grinding. And this is global, so this is not just here in the US, this is literally any country you can name, we've got users there. This is, I guess, a testament to the power of the service. Helping guys meet other guys seems to be very, very popular, and we love to do that for them. And the other kind of interesting fact is we're self-funded, so we have 2 versions of the app. We have a free version and a subscription service. The free version is ad-supported, and the subscription service is a monthly fee. And so between those 2 revenue streams, we support the business here, and and so we've never actually taken outside capital. And so something else we're very, very proud of is that we're committed to just creating great products and just doing the great thing for our users and for the team here, and not really worrying about investors and spending time on pitches and all these other things. We're focused on creating great products. So with that quick background, I'd love to introduce Lukas Sliwka, who's our VP of Engineering and the head of tech.
All right. And I broke the microphone. Okay, perfect. Welcome, everybody. Today we're going to take a deeper dive into iOS development, Xcode specifically. We're going to focus on a couple of areas that are very important to me. I joined Grindr 6 months ago, and Grindr experienced explosive growth as a company. And with that growth came a lot of development in terms of backend system, the front-end clients. And when you're in that mode, when you're growing so fast, a lot of times you're kind of throwing things together to keep up with the demand, right? And it shows, right? It shows on our backend systems, it shows on our front-end clients. The first talk that I did about 2 months ago, I talked about scalability. During that talk, I talked about what does it actually take to support millions and millions of users. And that's not an easy thing. Today, we're going to focus primarily on iOS side of things and how you can actually employ some of the strategies to best develop your iOS clients. Before we go on, I want to introduce a couple of people that are going to be helping me a lot with this conversation. So I'd like to introduce John King, who is our iOS developer and part of our iOS development team, and also Rudy Hakopian, who's our QA automation architect. And before I go forward, I want to kind of set the stage in terms of a lot of startups, a lot of applications being built. You have maybe 1 guy, 2 guys working out in the back room, throwing things together, right? And that's all great, as long as you know front end and back end, all the ins and outs of scaling your application, right? There's a big difference between handling 100 users versus 10,000 users versus 100,000 users, and the scales goes on. I mean, as your organization grows, you need to have certain specialties, right? However, when you look at startups, you need to stay agile. You need to have people who are kind of jacks of all trades, but at the same time, they are masters of few areas, right? So when you're trying to set up a very successful startup or company, mid-sized company that is very lean, You know, you can do a lot of with 15, 20 people, as long as these people are very passionate about technology, and you build a framework around them that allows them to innovate, fail fast, learn, rinse, and repeat, right? So we'll talk about some of that today. So let's start by discussing, you know, what we're going to talk about today. So specifically when it comes to iOS development, we're going to talk about test-driven development, TDD. We're going to talk about inversion of control. Another name for that is dependency injection. And we specifically use Typhoon container for that. We're going to also discuss dependency management powered by CocoaPods. And also we'll talk about build and release pipeline, and we'll talk about what makes a mature build and release pipeline for a mature organization. And I would like to set a little context why I want to talk about these things, right? When you're a company, when you're a startup, you want to have an environment that enables innovation, right? And my job here is to essentially build an engineering organization that promotes rapid change and rewards experimentation. And that's not an easy thing, right? As a developer, and maybe if I could get a head count, how many developers do we have in the room? People who actually write code. So most of you. So you know what I'm talking about, how difficult it is to be in an organization that has some production applications already supporting revenue, and that's locked in, and at the same time you're trying to deliver on new projects, and at the same time technology is moving so fast, you want to experiment with different technologies, possibly apply new things to improve things, and it's a constant battle between having a stable production environment that generates revenue, have a development engineering environment where you can innovate, and you can agree with product, right? Because product development also wants to deliver features. So it's a constant collaboration, and it's a constant negotiation between those different forces. So what I want to talk about today is what it means to have a strong engineering practice. When I started with Grindr 6 months ago, my main charter was to build a strong engineering practice. And what I mean by that is build a mature engineering practice that essentially enables people and allows people to experiment, allows teams to experiment, and possibly fail fast, learn without affecting revenue, without affecting these core business applications that's already running. Joel mentioned that we're a mature business. We are making money. We have a lot of users in over 190 countries around the world. We're processing massive traffic. Obviously, we're not Facebook. We're not Yahoo or whatever. But we deal with close to 200 to 500 messages per second when it comes to chat. We talk about traffic like 250,000 RPMs to 500,000 RPMs. We had days when we reached actually 1 million RPMs. Those are not easy things to withstand. And when you're designing your backend systems and also front-end clients, there needs to be a lot of thought put in how you orchestrate things, right? When it comes to the setting up strong engineering practice, however, there are a couple of different components that are part of that. And a lot of the stuff that we're going to talk about today are just like different building blocks of overall picture. So I just want to give you a context why we're doing it. Why are we doing TDD, or why are we using IOC Container, or why are we writing unit tests? It's not because it's something cool and everyone else is doing it. There's a purpose behind it, right? And the purpose for that is to have that strong engineering practice. And the strong engineering practice is composed of 3 components, which is process, technology, and people, right? I kind of touched already on people, and and who we hire, who we want to be part of our team. Our engineering team is very small. We have right now probably 15 to 20 people that are making this whole thing happen. They are divided into various different functional areas. So we have standard DevOps, NOC type of practice, we have QA practice, we have architecture practice, we have Android, iOS development, we have backend practice, and all these kind of practices have to come together in some way to create product, right? We use Agile and Scrum for that. I don't believe that any sort of modern software development should be using anything different. I think that waterfall is dead. I'm not afraid to say that. A lot of companies are claiming that they're Agile and Scrum. You know, in my opinion, if you have a status meeting in the morning that you call stand-up, that doesn't make you an Agile organization, right? There's much more to that. There's going to be a separate tech talk on that that I'm gonna kind of take a deeper dive. But there's also other things like Lean and test-driven development. There's KISS, which is keep it simple, stupid, right? Or Yagni, which is you're not gonna need it, right? Or metrics. And it all comes down to the fact that we want to move very fast. We want to have a process in place that kind of sets a cadence to day-to-day development, but we also, as an engineer organization, we have architectural principles in place that are being governed and watched for in terms of how we build software. In terms of technology, I am in certain business, right? So I am enabling gay community to meet as fast as possible. I'm not in the identity management business. I'm not in the business of building databases. I'm not in the business of a lot of other engineering aspects that are very cool for engineers to play with. However, that's not my core business. So it's very easy as an engineer to get caught up in the rabbit holes where, oh, you know what? I'm gonna build my own stuff, right? Because it's cool. That's not how we do things here, right? If we're looking at the overall ecosystem of Grindr application as a whole, you know, I want to channel the development effort into areas that haven't been done before, and maybe there are no appliances or frameworks on the market to do them. I want to make sure that I apply open source technologies, I buy whatever I need to buy, and I integrate to build a strong, solid platform that enables my team to do things that haven't been done before, right? I don't want to be in a business of building cool geospatial search algorithm, right? Because, you know, there are plenty of companies that are specializing in that, right? There are databases that have open source algorithm integrated inside them, like MongoDB uses Google geospatial search, right? So I want to leverage that. I don't want to build that from scratch. And when I joined Grindr, I looked at overall ecosystem. There's a lot of things that we're fixing because over the years, because we're moving so fast, it was easier to build things from scratch, as opposed to maybe take a step backward, look at overall architecture, and design things differently. So this year, what we're doing, we're redesigning backend. We're completely revamping our system, overall platform, as well as we're building clients. And when it comes to clients, it's kind of the same thing, right? When I look at Xcode and iOS development just recently last year introduced the version 7, which brought finally unit testing tools and an ability to do things that have been around for a very long time, right? And it's amazing to me a lot of times when I talk to iOS developers, and I want to offend anybody, how special iOS and Xcode development is. And I want to tell you that you're not special, right? And the reason why you're not special is because software engineering has been for a very long time, and the concepts that have just been introduced into your ecosystem has been around for a very long time. And there is a reason for that, right? And the reason for that is because for a very long time we've done object-oriented programming, and we've solved things through frameworks and micro frameworks and patterns, and those things should be applied, right? And Xcode and iOS development is not different from Java or any other language, right? So what I want to stress is that the things that we're going to be talking about today are maybe new things that were introduced quite recently into iOS development ecosystem, but they have a very strong foundation in computer science and a backing of at least 10 to 15, 20 years of object-oriented development. Okay? So when I talk about frameworks, containers, automation, that's something that we use here to essentially provide these tools, provide the technology and the frameworks and a process to allow our teams to experiment, learn, fail fast, and do it better next time, right? We work in 1 week sprint cycles, so that means that within 5 days you need to complete your development. You need to conform to your definition of done, which means that regression testing needs to be done. You need to have a certain level of quality. You cannot achieve that without automation and certain level of maturity as an engineering shop, right? So let's talk about, before we take the deeper dive, I wanted to throw some definitions out there for people who have not done before test-driven development, have not dealt with dependency management, or don't know what the inversion of control is. Essentially, those are tools in our tool bag that we can apply to make our development faster, better, more robust. And at the end of the day, we allow people to experiment with different frameworks, different technologies, different approaches, without worrying that we're going to push something in production that's going to bring me down and my revenue is going to stop, right? So I want to have a process in place as an engineering shop where I enable you guys to experiment, but in order to do that, I need some of these tools, right? I'm not going to go through that. You guys can look it up on Wiki. What I do want to do before we go into the code dive, I want to take a very brief moment to talk about inversion of control and testing. So I set up essentially a very simple scenario where I have a class Grindr that uses Grindr service. And normally, if you don't have any sort of containers around that stuff, you would just say, I would instantiate my new Grindr class. And if I'm referencing this Grindr service, I would have to have either in my constructor or right here some sort of way that I am instantiating this class, or I can do it within my business logic so it's populated, right? Now, when it comes to inversion of control, it's essentially a container that allows you to outsource, for the lack of a better word, the business of creation and wiring classes together, right? So if I have two classes like this, my IOC container is essentially a way for me to create this class through that container without me worrying about how that's done. Why it's important? Well, if I'm doing test-driven development, I want to have very atomic tests that are just testing this particular component, right? Which means I will have to most likely mock this service and mock the responsive of that service in order to have a valid test, right? Very high level. I'm not going to talk about more than that. I want to hand it off to John, who is going to actually look at some code, show you how it's done in Xcode, starting with dependency management using CocoaPods. Okay. I'll give you this. Very good.
Thank you, sir. You just clipped it to your...
Yeah, do that.
Awesome.
Cool.
You want to move that for a second?
Yeah.
Awesome. Thank you. Hey, everybody. As Lucas was kind enough to introduce me, I am John King. I am an iOS developer here at Grindr. Who here has not heard any of these concepts before tonight? Fair enough. All right. So the first thing I want to talk about is CocoaPods. Oh, Might help if you guys could see what I'm talking about, huh? Awesome. So CocoaPods is what we use for dependency management for our Grindr project. CocoaPods is itself simply a Ruby gem we install through terminal, which will keep a reference to all of the various Git repositories that are managed by CocoaPods and gives us a really easy way to put them into our project. To simply install it, we open our terminal and we gem install CocoaPods, just like you would any other Ruby gem. Simple enough. And if we go into Xcode, we can look at the key part of a CocoaPod. So this is called a pod file. A pod file is how we tell CocoaPods what dependencies we need for our project. This can be opened up as any simple text file, and that's exactly what this is. It's a text file with some glorified Ruby in it. Let's go ahead and break this down for a bit. So you can see we have a couple different build targets, if you're familiar with Xcode, that our entire workspace will build. For each target, we tell them what particular pods we need in order to build this project for the linker. A pod is just a CocoaPod term for just a framework that we use within this project. So you see we have 4 various targets. They use all very similar things. Next to them, you see a version number. This is an optional version number. If you omit the version number, it will always install the latest version. And at any time, you can run a different command called pod update, and it will take every dependency you're using and automatically update. We don't have to worry about, oh, has an update come out yet? Have we received an email about it? Before we release, let's go check and see if we have the latest versions of everything we're using. We simply use a pod update. For certain reasons, we have frozen every particular pod we're using. We're telling them, this is the version we want to use. Always go and get this version. CocoaPods uses a file called a pod spec to gather all this information about how it might build in with your project. For 90% of you developers, this is something you'll never have to work on unless you're building a pod for someone else to use. Pod specs they're there, you need to know they exist, and that's about it. This pod file is the more important thing. There is a particular command that you see here. It looks like a tilde arrow. We can actually do something like this, if we so desired, and this would give us the latest min version of that file, or of that pod, forgive me. So let's say I'm using YAML framework and they have a new, I'm sorry, go ahead. Oh yes, I'm so sorry. All right, I'll do the old-fashioned way. Do I have to go in properties? Preferences. That'll work. All right, how's that, guys? Whatever. Apple thinks this is a good presentation size. It's good enough for me. All right, so, forgive me. Sorry about that. Should have said something sooner, guys. So you see we have a tilde arrow here. We've replaced this with just our comma. So instead of using the version we've given it, it will use the latest min version, which is the second number here, available to us. So let's say YAML framework, as you see here, we currently use 0.02 of it. Let's say they have a new 1.0 release of it, but there's also an 0.03, a 0.10. It will give us the latest second number that there is available without moving to the next incremental. This is useful if we want to keep using a similar version that we have, but we are leery of using the latest and greatest in case there are any bugs, in case it doesn't seem to play right with our code for whatever reason. It's a handy little tool if you're using your own pod file. So this is the second most important part of the pod file to me. So we've got a post install hook, and this is our chance to write some Ruby code and do some things to help with integration with any of these pods. For example, we have a number of Xcode schemes that have their own particular settings to help us build and maintain the project. And oftentimes, just doing a pod install, very basic, will not transfer these settings over to that. Does not play nice. As I said earlier, a lot of what we need in order to make these libraries build properly with us is in that pod spec file that CocoaPods uses. Now, what I've done here is it's a bunch of fancy Ruby regex. All it does is take all those settings we need, copying them into what we'll be using, and then tells us it's done. Simple enough, but you may have any other use for that post install hook. It is a catch-all for we have downloaded and installed the pods, integrated them into the project. Do you need to do anything else? Here you go. It's important to note that after you run a pod install, it will generate something called an Xcode workspace. For most people, when you create a new Xcode project, you'll be using something called an XCproj, an Xcode project file, similar to a VCproj in Visual Studio. But we need to use multiple projects for this, and what CocoaPods will do is it'll automatically generate this Xcode workspace with everything we need for it. And that is the file you use from now on. You can forget about that Xcode project for time immemorial. Before we move on, does anyone want to ask any questions about CocoaPods, why you might use it, how it might be used? Sure.
So let's say you have multiple pods or say constant JSON.
I'm sorry, can you speak up?
If there are multiple pods or constant JSON, how would you determine which one to use?
Excellent question. So CocoaPods has an awesome website at cocoapods.org. Just like finding any other open framework, it can be difficult to just know what's out there, and then once you find what's out there, what's a good one to use. So I can go into cocoapods.org and I can type in a general idea of what I might be looking for. I've typed in JSON-kit here, and it tells me what pods are available for that. And all I have to do is plug in what I find here into my pod file. How do I pick one? That's kind of up to the individual developer. It's kind of like asking how do I determine what framework to use. Sometimes that just comes with individual knowledge. Sometimes it comes with trial and error. It's kind of a personal choice.
What I would suggest in those cases is that you do some sort of POCs. Right?
Indeed.
So if you're evaluating, let's say, 3-4 different frameworks, what we tend to do is we come up before with the evaluation criteria. So if you have 10 things that you're looking for, you simple Excel spreadsheet. On the left-hand side, you've got your criteria, you list all the frameworks at the top, and then you can actually write little POCs using each and test the performance or whatever, and then you can have actual metrics behind which one you want to use. Another thing that you have to also look at is the especially if it's an open source project, how active it is. Right?
Indeed.
How many people you have committing to it. So you have whatever, GitHub or whatever repository they use. It's good to check how actively they're updating it, right?
Do you have any other questions? Sure.
I'm kind of new in this environment. I come here from ERP, but those variable parameters that you have on the pods, they're like hard-coded?
Which parameters are we talking about?
Like, this thing, the target, say like walk word, 0.02, all these variables.
Correct.
They're hard-coded?
These are hard-coded version numbers, saying that these are the version numbers we want to use. Do not use anything later, do not use anything older, use only this version.
You have a choice to actually select something that will automatically load the latest version. That's very dangerous, right? Because what if they deprecated some stuff and all of a sudden you do a build and your stuff breaks, right? So you need to have a higher ceremony when it comes to dependency libraries, when it comes to updating, and it's usually a project that you want to schedule. Like, okay, there's a newer library for this. Let's actually have a user story in your Agile board for that, so you can actually regression test your stuff. Thank you.
Very cool. Anybody else before we move on? Awesome. So the next thing I would like to talk to you guys about is the Typhoon framework. The Typhoon framework is the dependency injection or IOC container we use within Grindr. There are a couple IOC containers out there. You find some smaller projects on GitHub, but a lot of them are either not being supported anymore, I should say, or have very little adoption. But Typhoon seems to have risen to the top. If you look online for any number of time for an IOC container for Objective-C, you'll see Typhoon's name listed a number of times. And it can be found at typhoonframework.org. And from their website, you can go to their GitHub page. There is also a CocoaPod for Typhoon in order to integrate it in. So let's talk about some of the base things about using Typhoon. So the base part about going into Typhoon is you have these logical groupings called assemblies. Assemblies are a group of related instance classes that will be used. These are later fed to our creation factory, and they are how we will access them later. So you see I've created a class here called endpoint log assembly, and it's derived from Typhoon assembly. All assemblies are derived from Typhoon assembly, and we return a type ID, and we have various instances that we will need to retrieve. Within our implementation file, wow, this is big. We tell Typhoon, we give our class that what we need, and then we have a chance to do some things to it before it's returned. So for example, for the endpoint log, we're telling it, hey, this is the class we need, and we need to inject it with this property, which is also shared within the assembly, which is our endpoint log entry factory. And we're also setting the scope. Setting the scope is a really important thing and kind of can be difficult to understand for some things. So there are 4 major types of scopes. The first one is Typhoon scope prototype, which anytime we request this object, we will get a brand new instance of it every time, no reuse. The second and the default is type object scope graph. If you do not specify a scope, this is what it will do by default. Object graph scope, rather, forgive me, is an interesting choice. I'm a big fan of it. So let's say I'm in a view controller and I have some sort of delegate, and there's an object we need to pass between them. Let's say within our code base, there's also another view controller and delegate that has a similar object. So we don't really have a singleton that's passed between them, and we don't want to have to try and pass an object back and forth. With Typhoon object scope graph, anytime we request that object, we will receive the same one within a similar frame of execution. So let's say I've requested this view controller from Typhoon for whatever reason, and I'm working within it, doing some things, and I request something else within it. It will return me a new instance of that object. I've now gone somewhere else within this execution stack, and I request that object again. It's going to return me the same object, no different, the same one. And now I've gone out of it, and I've gone into a new view controller who does something else. It will get a new instance, and its delegate will get the same instance of that. It's very handy, very, very handy. The third type of scope you see here on the board is Typhoon scope singleton. Does everyone know what a singleton is? One and only one? Awesome. There's also a fourth type called weak singleton. A weak singleton is just like a weak property. It zeroes out if nobody has a reference to it. Awesome. So let's talk about how these assemblies are used. Does anyone have any questions about the assembly before we move forward? Very cool. So, not very good with. Can I use built-in retina display?
Should be a little bit better.
That'll work. All right, so you see here, I'm initializing a Typhoon component factory, and I'm feeding it a number of assemblies. You see I have, it's a little difficult to read here, forgive me. This is an array of various assemblies we have within the project. And these are all the different assemblies it will manage. Right. Now is a good time. Let's see. Bear with me just one moment. So the question comes up, how do we access this factory at runtime when we want to retrieve things from it. So there is a protocol we can use for our classes called Typhoon Component Factory Aware. Whenever any of our instances get initialized through Typhoon and we are Typhoon Component Factory Aware, it will call set factory on that object, and we now have a reference to whatever factory we are associated with and can retrieve anything from those assemblies, anything from our own assembly. And it's fantastic because all we have to do is cast the factory as an assembly and call the method as normal. If we are not Typhoon Component Factory Aware, there is a convenience method called makeDefault, and we now have a default factory that we can access anywhere else. This is mainly for use in legacy code. Now, I will touch on Typhoon again when we start talking about unit testing. Does anyone have any questions about basic use of Typhoon? Very cool. All right. So who here has done unit testing in iOS? All right. Tell me, how easy did you find it to use?
So it's my first time. So.
Fair enough. How about you, sir? How easy did you find unit testing to be done in Xcode? A little bit, yeah. A little bit, yeah. So in order to do any unit testing in iOS, we create an instance of a class called XCTestCase. We derive from it, we name it, we've got a new class. Unlike other classes which Xcode will create for you, we only have an implementation file. You can have a header file, but there's typically no need for it. There are 5 major methods to know in any unit test environment, within any unit test, I should say. We have a class level setup, and this is a chance to do any type of initialization before any tests are run at the class level. This is run only once before all testing. We then have an instance level setup, which we run before any test is run. So this is our chance to set up any variables, get the environment a certain way, and it will be run once for every test case. And then it will then run any method that begins with the word lowercase test. Objective-C is definitely coding by convention, and this is a good example of that. It will go through any method that begins with the word test, no matter how it ends, and run each of those. And then after each test, it will run an instance level teardown, which is our chance to clean up after ourselves. And after all tests are run, we have another class level teardown, which is a chance to clean up anything we've left over for the test as a whole. In order to run our unit test, we simply hit Command U. It'll open up the simulator for you. We'll begin running our tests. You can see them pass in real time if you have your particular code file open. And once at the end, that all of our tests have succeeded. If we see a failing test, it will tell us overall that all of our tests have failed, and it will give us where it is and whatever particular error message we have printed out. There we go. Interesting. So we determine whether or not a test has failed through various Xcode asserts. And we can see we have a number of different assertions. Let's say you're brand new to unit testing, you don't know any of these. This is all you have to do, XCT assert. This is just like a standard NS assert. Any false value will throw an exception and we'll have to fail to test. One thing that's incredibly important for at least our unit tests, and I would argue most unit tests, is the ability to mock objects. In unit testing, we try to keep things, we only want to be unit testing the class our tests are built for. We're not doing integration testing. We're not testing how it talks to any other class or even our backend. So we use what's called mock objects. Are most people familiar with that term, mock objects? Very cool. So one deficiency that the Xcode testing suite has is that it does not include any type of mock library. There's no ability to create a mock object natively. There are a number of libraries useful. The one we use in-house is called OC-mock. Once again, this is another really popular library. You see lots of widespread use of this. There are a couple, I'd like to touch on just some of the highlights of mocks and some of the important methods you would use for this. So there are two different type of mock objects you would use. One is a more traditional mock object where it will only expect methods that you have told it to expect, and if it receives anything else, it throws an exception and fails the test. We have another type called a nice mock, and we can, side note, we can mock both classes and protocols. A nice mock of a class or protocol will simply accept anything you throw at it, but not return anything for those values. It will simply return nil. So we also have the method called expect on mock objects. And the expect method gives us, we tell this mock object, hey, I am expecting this method to be called. When I later call another method, which I'll go over next, if you did not receive this message, then you need to throw an exception and fail the test. The method we call at the end of our test in order to determine that all expected methods have been called is called verify. Let's say we simply need to stub a method. There's a handy dandy little method called stub. And we feed it what method we expect, and we can also give it a return value in order for it to work nicely with anything else we may be testing. The last thing I wanted to talk about in terms of unit testing is I wanted to touch on Typhoon again, and I wanted to talk about the Typhoon patcher class. If you'll give me just one moment. So the great thing about the Typhoon factory and the assemblies is we set everything up and we go to runtime and it works as expected. Let's say I'm writing a unit test and the class I'm unit testing uses some things from the Typhoon factory, but we do not want something from the production assembly. This is a very common case. We don't want to, like I said, we don't want to drag in any other classes that were not responsible for unit testing in this particular test. In order to do that, we create our factory with whatever assemblies we need, just as we normally would, and then we create an instance of Typhoon Patcher. What Typhoon Patcher does is it gives us at runtime the ability to modify what that factory will return. So you see what we've done here is for the factory we've created here, which includes just the endpoint log assembly, we patch in for the endpoint log assembly, or for the endpoint log entry factory, forgive me, method, we create a mock endpoint log entry factory, tell it to expect and return some things, and return that. And in order to give that information to the factory, we then attach it as a post-processor, and from that point forward, that factory will return our mock object that we expect. All right, and that, I believe, is all the code examples I have for unit testing CocoaPods and Typhoon. Who wants? Sure.
Yeah, so within the unit testing, do you have like development, QA, and production environment, or how was it?
Our unit tests are run on, Rudy can talk about this next. Our unit tests are run as part of our continuous integration environment, though we do run them locally before we commit.
So the idea of unit tests is that that's a suite that I'm expecting every developer to execute when they are making code changes on their local environment. But it's also part of our continuous integration environment, which we'll talk about the build pipeline. So whatever you checked into repository, then there's checked out in a continuous integration process, and those unit tests are run again.
Certainly.
While testing non-UI related code,
Mm-hmm.
can you run it outside an emulator or simulator?
The simulator runs every time. It doesn't run on a device. It does not run outside of anything else. The simulator will open every time. You don't see anything. Nothing. The app itself doesn't run. It's only running the unit tests.
But you can't just use the native speed of your computer just to run the test.
Keep in mind, the iPhone simulator is not an emulator. It is, you will get a speed of the device you're using, but no, it will not run from the Mac OS. Unless you're, one caveat to that, unless you're not doing an iOS app and you're doing a Cocoa app, an actual Mac application, then they'll run in its native environment. Yes, through mock objects specifically, when we are expecting a particular method, as an argument for whatever method we're expecting, we can give it either the value that we expect it to get, which will, and if it does not receive that value, the test will fail, or we can give it an instance of a class called OCM-arg, which you can do some fancy things with it and to determine, do some logic to determine what it passed in and does this pass certain variables, or we can just take anything. Whatever it passes, we don't really care, just we have to have something to be able to accept it.
What if we need to call a method twice? How do we specify that?
You simply expect it twice. Every time you call expect on it, it's going to add another, it's going to increment a sort of counter, and every time it's called, it's going to take one off the stack, and then take it off the stack again if we've expected it twice. And if it receives another one, then it fails, because it was not expecting it that many times.
Cool. I think we talked about a couple of very important concepts. So again, CocoaPods allow us to manage dependencies. You saw a lot of libraries being used. aws-opsworks, for example, so you want to have an ecosystem that is managed through a framework, how we load these things. Typhoon framework, again, allows us to essentially delegate the factory functionality to a container, which then is a byproduct of that, is allows us to essentially write unit tests, and essentially we can kind of isolate classes and write very specific tests for those classes. If there are any dependencies between those classes, Typhoon can essentially patch those classes as OC mock objects. So we essentially can write very expected returns or very expected results for execution, so our tests are very atomic, right? And that's very important. You don't want to be testing 50,000 dependencies as one. You want to unit test your one class, right? And it's a very important distinction to make between unit testing and functional testing. Functional testing allows you to test a lot of different things. You're focusing on business logic, and you can use automation for that. And that's a different topic, right? So let me talk about build process and how it all kind of comes together with the delivery to production. And I'm going to start by showing you where we were 6 months ago. And let me click on that. So, well, that's not cool. Let me do that. And let me do that. Can you guys see that or no? Okay, let's do this. So, so this is essentially a diagram of how our release management process look like. So let me very quickly focus on a couple of key areas here. So if you've done iOS development, you know the concept of provisioning profiles, certificates. There are various different types: enterprise, ad hoc, production, obviously development. So the way this used to work is that we actually had our iOS developers maintaining all these certificates through iTunes Connect. And then they would do their development on the iOS machines and essentially stop it. And then they would essentially do their local testing by checking out these certificates that we would export to our Bitbucket repository to do their local essentially build, which was, we would run Xcode build, it would create Grindr.app, they would then sign it with the development provisioning profiles and their certificates, and then now we are able to test on our device, right, on the local machine. And then they would check in that code into Bitbucket. And then we would use our Jenkins process to kind of check the code out and go through the same process again where we kind of do Xcode build, we create Grindr.app, we sign it with any of those, and we would have a publishing process that would create these IPAs for enterprise, ad hoc, and then when we would use Hockey app we're using UTest for crowdsourcing our tests, and also our internal QA would then use the ad hoc builds to test, right? Now, where it gets really funny is that now, okay, I've done all my testing, it's great, and I'm ready to go to production. And then what happens? iOS developers checks out the code to their local box, and they go through this build process, and on their local box, they're signing the APP with the production provisioning profiles, and then we would upload to iTunes, and then eventually would get to the App Store. Now, when we talk about mature, build release management processes, there's a lot of problems here. Number one, developers have access to production and certificates and provisioning profiling, allowing them to essentially deploy stuff to production. That's not necessarily what I want, right? Another thing is, what I'm testing here is really not what I'm deploying. There is no release candidate, right? Because, okay, I'm going to go through all this effort, and now if my developer foo-bars their checkout, or if someone between me doing testing goes in here and checks in some additional code, then my checkout will catch that. And in fact, we had a couple of instances where we pushed stuff to production that we really didn't want. Amazingly so, this is probably majority of iOS development shop do it that way. And the reason why is because for whatever reason, the tools are not there, the environment is not mature to automate this process. So we've actually spent a lot of time and effort to build a release management pipeline to do it more like this, which is our new release process, which is we have obviously these provisioning profiles, we have release management function that maintains these. There's a separate Bitbucket repository that governs these things with separate permissions, so developers do not have access to that stuff, right? Developers can only do development on their iOS machines. They do this process, they use the development provisioning profiles to do unit testing, local testing, but then once we get to the Jenkins box, right, Jenkins box actually checks out the code, checks out the provisioning profiles, does through the build process. It creates the versioned release candidate that is then checked into Nexus artifact repository before the signing process. So that's my release candidate. My APP is now a release candidate, which I then can draw from and publish to different environments. Once I certify, then I use the same artifact from Nexus artifact repository. I'm going to check it out, sign it with production provisioning profile, and push to App Store. And that is being done by my release management, not by my developers, right? And that's more in line with the mature enterprise build pipeline release management process. Questions?
Do they have two different iTunes accounts, or are there two different developers, Apple?
Yeah, so essentially developers don't have access to yeah. Okay, so that's really what you want. I mean, key here is the release candidate and actually use the usage of artifact repository, right? Another thing is Sonar. We'll talk about code metrics. I'm very big about having empirical data about what my code is like. It's not a water cooler conversation. I want to see actual metrics. There are standard metrics to measure the quality of my code. We'll see that a little bit. And also, I want to have automated testing as part of that process. So this build, every time I do build, right, there's going to be unit testing. I'm going to calculate my metrics. I'm going to also run my automated functional testing, and that's future. We are working on that right now. We are doing a big push to have that done by the end of summer. At the end of the day, every time I do a build, I want to couple of things get done. I want to calculate my code quality metrics, and I want to fail the build if someone wrote something without a unit test, which means my code coverage percentage decreased. Also, you know, if my unit tests fail, obviously I want to fail the build. And then on top of that, once the artifact is done, I want to run my automated testing using functional tests, which means that now I'm actually testing the app functionality, right? And that should happen every night, at least, right? So now developers can innovate, they can do whatever, they can test different frameworks. There's a harness in place to fail fast, preventing me from pushing crap to production, right? So, let's talk about how it's actually implemented. So Rudy, if you could take over and talk about our Jenkins setup and the pipeline.
All right. Hi guys. So I'm gonna go through some of the stuff that Lukas and John went through in a little more detail about how the builds are happening, how the artifacts are stored, how do we track them, and what do we do with them after QA signs off on them, right? So Lukas briefly mentioned, now what we do is we basically store everything we built. So I'm going to start with a couple tools that we're actually using in-house. So we're using Jenkins for all the build processes. So we use Jenkins to build the artifacts. We use Sonar, if you guys are familiar with it, for reporting. So what we do is after we build, we run the code quality metrics and report it to Sonar. So I'm going to pull up Sonar and show you guys the dashboard. It basically tells you where the violations are, what code is missing unit test coverage. If they added 5 classes and they haven't unit tested, obviously the coverage percentage drops. So we can flag it as a failure and ship it back to the dev team before it even makes it to QA. We're using Nexus. It's an artifact repository. So what we do is after we have the APP and the IPA artifacts, we store them there for tracking purposes with appropriate Git hashes. So we can trace it back to which Git commits they were associated with, and we can troubleshoot them if we need to. And Hockey app, obviously most of you guys are familiar with it, to doing distribution of the IPAs. So I'm going to start with the iOS. So with the Jenkins piece, so what we do is we basically use Jenkins to build the artifacts. What we've done is our new build process basically is we're tying down a couple different moving parts together to make this happen. So first we start off with code quality metrics. Do they pass? If it does pass the code quality and we're good with that, they have done proper unit testing, all unit tests pass, they haven't broken anything existing, we go ahead and build the app. Once we build the app, all this stuff is still done in Jenkins. Jenkins will build the app after doing the reporting to Sonar and store the artifact over at the Nexus repository. If all that stuff is successful, which means we have a proper IPA with the right provisioning profile signed, we ship that artifact out to Hockey app for QA to be able to download and take a look at it. So here is some of the individual artifacts. We have an Xcode build that does the actual build. We have the code quality metrics that we run right before we run the build. So I'm going to open up one of the jobs where you can actually see how it's tied together. So this is an example of it first. So first we do the code quality. If it is successful, we move on with Xcode build. And then if that is successful, we move on to storing the artifact, which at that point we contact Nexus and we ship out the artifact for storage and retrieval. And we sign it with the appropriate artifact and we store those. The builds itself take about 5 to 10 minutes. So with all this stuff included, so from the time that go ahead, sorry.
When does the build get triggered?
So we have 2 versions of it, right? We have a polling system, which we keep polling the repository every 10 minutes. If there are new commits, we just check it out, we build it. It kind of automatically.
On any branch?
Yeah, we have a few active branches that we have jobs set up for. And then we have master and kind of stable branch, which is kind of always production-like plus. The other option is QA can always trigger it if they want to, right? So those are the options that we have built in. And then we're also working on refining what the proper incremental time frame should be for polling. Is it too frequent or not frequent enough, right? Because if the builds take about 10 minutes, you don't want to keep pulling every 5 minutes. And then you have your jobs lined up and queued up, and it's just going to bog down Jenkins itself. So, any other questions? So for what we do is with the code quality metrics, let me just pull it up. So after everything is done, you'll see that the build is successful. And this is basically Sonar. So what we do is we gather all that statistic from unit testing that John went through, and we report it to this tool called Sonar Cubes. What it does is it basically aggregates it, and you see the 2 green graphs there for each branch right now. So as we keep working on branches and committing code, the code quality is run, and reports are getting generated and updated. If you start missing your commitment, let's say threshold is set at 90% for unit test coverage, and you add 10 new classes and you have no unit test, you're obviously going to cut off on that threshold and not meet it. So we're going to flag it, and once we ship the results here, you're going to see red and yellow and going all the way down to red, obviously. We can actually enable triggers on these jobs, on this reporting, and say, in this case, we have actually coverage set to, if it's greater than 65%, mark it as a warning. If it's greater than 70%, fail the build. So when the build fails, it gets kicked back to the dev team, and they're like, all right, we got to address this. This is not making it to QA, because the next step is actually the build process, and that never got triggered. So QA has nothing to test on.
Let me touch a little bit on that. So,
sure.
so from the perspective of having metrics, how well you're doing as an engineering organization, this dashboard is very important to me, right? Because we have multiple teams, we have multiple, you've got Android, you've got iOS, you've got backend, you've got multiple branches. Setting rules and having these static code analyzer rules that the team over time develops is very important, right? Because those are essentially your automated code reviews that happen every time you build, right? So as you're developing these, you're getting better and better and better. So you can make this part of your retrospective process if you want. You can make it more collaborative when developers updating it all the time. The bottom line is those are very important. Another metrics that I look at is comments density, right? So you want to make sure that your code is well documented. I'm not big of writing separate documents from the code. I think that the code in the class is very important. Also, that's on top of naming standards and conventions or whatever. Obviously, if you name your classes correctly, if you name your method correctly, you don't need comments, but if you don't, then, that's a problem. Duplications, that's very important for me as well. I don't want copy and paste, right? It's very easy if you're banging out stuff. You'd be like, okay, that looks cool, I'm just gonna reuse it, copy and paste. If that goes up, I'm not a very happy person, right? And then that's something that we're actually trying to make work. Cyclomatic complexity is also a very good metrics to look at. Anything greater than 5, I usually reject the build. So that's analogous with having God objects, right? If I have a class with 10,000 lines and does everything, cyclomatic complexity goes through the roof. I want nice, clean decomposition, right? So cyclomatic complexity is one way to ensure that you have that. And then our good old unit test coverage. So obviously, we want this number to be around 80%. Obviously, you're never going to have 100% coverage. You may strive for that, but I use 80-20 rule. 80% of code coverage is good. The bottom line is that if you set the threshold and you set up your failure SLA, you're kind of saying, okay, engineering, we have 60% now. From now on, whatever you check in, you cannot decrease this number. You can only go up, right? Which means now you're forcing your developers to write code that have proper unit tests in place. And now that's part of your automated process. You don't have to rely on humans to do code reviews or whatever. It's part of your build pipeline.
And you can kind of help. Yeah, go ahead.
Does Sonar just sit on top of your repository? Does it sit on GitHub?
No, this is a separate thing. This is a separate application. So what it does is when Jenkins builds it and it runs your unit test coverage, it actually publishes the numbers to Sonar. Sonar takes them, figures out what to do with them, and then does the whole graphing for you.
Oh, okay.
So it's kind of creating a link between Sonar and the Jenkins unit test reporting, and it just takes care of everything else.
And you said that when Jenkins builds it, it's into Sonar?
Yeah, Sonar it spills the reports to Sonar.
Okay.
So actually, I'm gonna do one thing for the demo right now, and then I'll carry on, and you guys can see the difference. So I'm gonna go to alerts, and you noticed how the coverage was. So I want it to fail and give me a warning at 80% and fail at 90%, right? So I'm just going to trigger a build right now, and we can continue.
So what is it building from? Is everybody ready to common file or server somewhere?
No, this is checking out the code repository, right? A given branch, and running the unit test coverage and doing the reports. If that is successful and Sonar doesn't report a failure on that, which means you haven't exceeded any of the thresholds, right? You're still good. And then Jenkins carries on with doing the build and then storing the artifact.
We set up a build pipeline templates through Jenkins. So there's a wizard that we have that allows you to specify the branch. And you enter the branch, you enter the provisioning profile, and that sets all those builds for you with all those multi-steps build process. And then you just schedule it and run it. So let's say I have I've been developing on my feature branches. I've been checking to stable. I'm ready I've got enough stuff to do a release candidate. I would cut the release branch, and then I would go to Jenkins, use my wizard to set up release branch build, and now we're building against it. Right? There's also a stable branch that we build against all the time, and that's all in Bitbucket.
So kind of the moving pieces for getting a build ready for QA is basically checking the code, having proper unit test coverage. We run the unit test coverage. If everything passes, we run the build, we create the artifact. If that is successful, we store it over at Nexus. And then and that's the raw APP file, right? So at that point, we can sign it with any provisioning profile we need, which is an issue that Lukas mentioned that they were having earlier, which is once QA signs off, the developer checks out the code again and does a brand new build. That's all gone now. Right, we have the actual raw APP that QA signed off on, depending on which provisioning profile we used. If they sign off on that, we check out the exact APP file, we sign it with production, and we ship that same thing off to Apple. Now, dev could have messed around with the branch as much as they wanted. That one build is going out the way QA signed off on, right? There's no more ifs and buts. Did we check out the right stuff? Did we build it properly? Did you guys update any libraries locally before building? So.
So how are you handling all the different devices in OS right now? I'm testing the different devices for OS and implementation of all those things.
So there's a difference between unit testing. So remember, unit testing is just automation. The functional testing automation, that's a different topic. We're gonna have a tech talk on that end of July.
Okay.
When you're running the simulator for all your unit tests, do you ever run into issues that it's not the actual device,
Yes.
like I don't know, integers? Or
So testing on a simulator is not going to ever be the same like testing on the real device. Right? So when you're setting up the functional automation framework, you want to make sure that you're using an actual device farm. There are companies that allow you to do that. Or you can have the farmed over devices in-house, but then you're stuck managing all that stuff. Again, that's end of July conversation.
To this point, what about the iOS 6 version with iOS 7? Or have you just said we're going to do iOS 7?
Do iOS 7, we usually trust the latest version.
Because that's where everybody percentages on.
But we have QA, in the QA process, we test against different devices.
Okay, we use different versions of it.
Cool. So as part of the build deployment process basically once all the builds are ready to go and there's no issues. So this is Nexus. I don't know how many of you guys are familiar with Nexus. It's basically a artifact dependency management system that we put in place. It's open source. You guys can utilize it as well. What we do is basically after all the artifacts are ready to go, I'll show you guys this version actually. We store them with the brand, can you guys see this? Yeah. With the version number and the build number that came through. And if you guys actually expand that, you have multiple versions. You have the ad hoc IPA, you have the dev IPA, and then you have the tarball, which is the actual raw app file. So once QA signs off on this version, let's say, which they did, we check out the tarball, which contains the raw app file. We sign it with production. We store them here so we know exactly what we released, and we ship this one off to the dev, to Apple Store. So if dev messed up with the branch at any time while QA was testing 2016-2, nobody's going to get impacted by it. We'll have to do some branch cleanup later, but the same artifact is going to make it to production and to the App Store. We also store the Git hash with it. So at any point, we can track it back and figure out this version was built based on this Git hash. So we can check it out and figure out what went wrong, if anything, right? So QA will be doing, so once these are ready and they're stored on Nexus, we ship them off to Hockey App, which is the application distribution portal, basically. The devices connect to it, they download it, they install it, they go off testing. One of the issues we were having was basically QA could never figure out which build they're testing because they're all 2016s, right? We managed to do custom build numbers. So they actually associate to individual Jenkins builds. So we can go back and say, okay, so version 5 is actually on Hockey App to be downloaded and tested. So when they're downloading, they actually see the latest downloadable version, and they can correlate to know whether the build they're downloading is actually from the last commit or is it from the previous one, right? Because the upload to Hockey App could have failed, something might have gone wrong, and then they're just downloading and updating, they might never know, right? They'll get to download this stuff, test it out. Once they're good with it, we'll go back to our Jenkins. We have a process. We have a process where we basically prepare for production. And what it does is basically given a version number and a build number, it checks out the tarball, which contains the app, signs it with production profile, and then uploads it back to Nexus, which is available to download. So you can actually click on it, download it, and then submit it to the Apple Store. Now this is done between the release management and the product owners, and we collaborate and figure out when the right time for release is, and we just go through this. So at any time, something that was tested is sort of what gets released at this point. So, any questions on any of this setup?
Yeah, sure. So when you submit it for certification with Apple, does Apple use some of this tool to verify that you, in fact, that you build it in, or like, because Apple says, okay, I want to see your Sonar Q reporting.
No. Apple doesn't care about Sonar reporting. Apple doesn't care about unit testing, any of that stuff.
Their evaluation criteria is based on completely different things, right?
Right.
Versus what we want to do. So again, tying it back to what we talked about, we want to enforce engineering standard, code quality, architectural standards, make sure that there's a separation between development and release management, right? There are tools to do that. We talked about Typhoon, CocoaPods, all that stuff. But it all comes together, right? For you able to be comfortable with experimenting and writing code, and be in an environment where we fail fast, right? We learn from that and we fix it, and then we move on.
Yeah.
Most people use version and build very differently in different places. I like the way you guys actually implemented that in Xcode, and that actually is automatically built in, right?
Yeah.
My question is this though: how do you actually your backend? How do you make sure that the new feature that you have that you're putting in there is always connected to that backend? How do you tie that all together?
You're talking about so our application is powered by RESTful APIs, which are versioned.
Yeah.
It's a completely different topic. How you manage your RESTful APIs.
But how do you Okay.
All I can tell you is that when it comes to like testing, you know, we have a staging environment, QA environment, so you're testing against certain version of APIs. There are ways also for you to set automated testing where you are essentially mocking the responses or mocking the JSONs. You can use man in the middle or some other proxy where you're essentially replaying back certain things, which kind of goes with like you want to have atomic tests. That's something that we're working on right now. It's part of our automation plan.
So it's not really automated quite yet to be line correct.
No. So we are doing a big push towards functional testing automation. Majority of our tests are right now on the QA side manual, and we use crowdsourcing through UTest to test our application. So as far as roadmap is concerned, we're a big push on the engineering side to do test-driven development, increase test code coverage, right? And then on the QA side, we're also just starting the automation effort. So we'll be employing some sort of a device farm. We'll essentially be able to replay scripts and simulate user behavior.
So it sounds like when you started this test-driven development, you had a pretty mature app and there were no unit tests, right? Or
correct.
Very few. So how did you prioritize how many unit tests to build? Did you put all of your engineering development on hold while you got up to 50%?
No.
Or did you write unit tests for bugs as they came up?
How expensive is that?
So it's really a Scrum discussion, right? How do you find that balance between like building your engineering practice versus your product priorities and everything else? All I can tell you is that we're solving for stability and essentially availability of the app, right? And you know, when I'm having discussion with my boss or with product, you know, it's kind of a horse trading thing where it's like, okay, well, you know, we could be cranking out a lot of features, but if we're crashing all the time, if the app is not stable, then that's not ideal. So you need to find a middle ground, right? The way we've solved that problem is that we said, okay, we made unit testing part of our definition of done, which means that if you're building a new feature, then you have to write it. If you're touching an old class, right, then you have to write a unit test for that class. So over time, your test coverage increases, right?
What is the engineering response to that?
What's that?
I mean, other than they have no say-so, but what is the engineering response to actually?
We actually made this decision collaboratively. It wasn't my mandate. I'm not a big fan of just be very heavy-handed. It was a discussion, right? And we kind of weighed the pros and cons, different approaches. At the end of the day, I think all developers say, yeah, it's going to be kind of sucky to do this, but we all got on board because at the end of the day, you know, we take pride in what we do, so we want to ship quality code. Okay. No more questions? Yes, sir.
Yeah, I don't know if this is appropriate because are you guys using Flurry, and so how?
Yes, so it's a separate topic. We are using Flurry. We're using actually several different libraries. Flurry is just part of many. So again, it's kind of goes with this motto of like, you don't want to be in a business of writing all that stuff from scratch, right? So if you want analytics, all this other stuff, you want to integrate with some sort of a company that's in the business of that, so that leaves you free to do other things, right? But that's a separate topic.